Hey guys, welcome to another course of Friendly Academy YouTube channel. Now in this video, you are going to learn how to build stream processing applications in AWS Cloud. And we are going to learn two services in particular, AWS Kinesis or Amazon Kinesis service and AWS Lambda. So we'll learn how these two services work together, and we are going to learn about all the theories, and then we will have some good hands-on experience by building a small stream processing application as well, so that you will easily understand all the theories much better. You can find the description in the YouTube description section. So without any further ado, let's get started. By the way, if you like these videos, make sure you like it and share with your friends as well. Hey everyone. So in this crash course, we are going to learn about stream processing with Amazon Kinesis and AWS Lambda. Let's get started. To start our discussion, let's understand what Kinesis is. Now, Kinesis is an AWS managed service. Now, this service is used to collect, process, and analyze real-time stream data. Why do we analyze this real-time stream data? Because we can get timely insight and react to new information. So why do we need this timely insight? Because if you look at this diagram below, it shows the value of the data versus the time. So as you can see, if you can extract the information early on, the value of that information is really high. Now, for example, let's imagine that there's a bank who analyzes all the ATM events of its entire ATM network. So while it is analyzing these events, if it detects any suspicious kind of fraudulent activities, it detects them in real time, and maybe it'll inform to the customer directly as well. Now, such information will be really useful, and it will be useful to the bank as well as to the customer. Now, in contrast to analyzing them in real time, if you analyze them, let's say every 12 hours or at midnight, probably it might identify that there are some fraudulent activity happened, but the damage is done, right? So we need quick action. So in order to get quick actions, we need to process information in real time. So that's where this real-time stream processing comes in handy. And that's why AWS introduced Kinesis. And Kinesis actually have four main services rather. So first one is Kinesis Data Stream, and then Kinesis Firehose, Kinesis Data Analytics, and Kinesis Video Streams. So Kinesis Data Streams is the main managed service where it can ingest real-time data. So data as in events, records, messages, so whatever the name that we use, we can ingest them and in real time, and then we can attach consumers to consume these messages. And then we have Kinesis Firehose. Kinesis Firehose is essentially to transport data to different targets. Now, this service can also ingest real-time data, but it's essentially used to transport data to different targets, such as, let's say, to an S3 bucket. And when it does it in near real time, not the real time way. So that is the main difference between Kinesis Firehose and Kinesis Data Stream. And the other main difference is Kinesis Firehose is a completely serverless service. So you don't have to pay for any provision resources, unless of course you are using this particular service. But however, with Kinesis Data Stream, you can process data in real time. And then we have Kinesis Data Analytics. So this particular service we can use to process data in real time again with standard SQL. And you can also host real-time processing frameworks such as Apache Flink to process this data in real time. Now particularly Apache Flink is extremely fast real-time processing framework. So you can easily use that as well. Or you can also use standard SQL. And then we have Kinesis Video Stream. So Kinesis Video Stream is essentially you can analyze video streams in contrast to data streams. But today in this crash course, we are focusing on Kinesis Data Streams and how can we use AWS Lambda to process the data that we stream through this Kinesis Data Stream. To get started, let's talk about Kinesis Data Stream and how it is built. Now you can go to Kinesis and create a Kinesis Data Stream. So once you create a Kinesis Data Stream, you can essentially decide how many shards do you need to include in that particular Kinesis data stream. Now for a given data stream, you can have one or more shards. And when your producers produce data into this Kinesis data stream, they are added to these shards. Now, when we are adding a message or an event or a record, whatever we call it, to a stream, we can define a partition key or PK. So when we define the PK, we have a hash function that is used inside this Kinesis service that will determine to which shard that message should be pushed into. And that will guarantee whatever the records that contains the same partition key will be landed onto the same shard. And that's the way we guarantee the ordered processing in Kinesis. Because when we attach a consumer in the other side, it can consume messages from a given shard in the order that they arrive. So that way we'll be processing the messages in order, but this order is only guaranteed within the shard. We'll talk more about that a little bit later. If you don't understand it right now, don't worry. So in this crash course, we are going to talk about AWS Lambda as a consumer. So we're not talking about EC2 instances or containers that will be pulling these messages, but we are going to use AWS Lambda. This is a serverless consumer, which will be consuming from a Kinesis stream and then process those messages. Before we learn about that, let's understand how data ingestion and consumption happens in a Kinesis data stream. So for a given Kinesis data stream, I already mentioned we can ingest data and then we can attach consumers to consume those data. And when you ingest data, they are added to shards. So you can have one or more shards, and there's a soft limits of 500 or 200 shards per stream. And that depends on different AWS region. Certain regions supports 500 shards per stream and or 200 shards per stream. And of course, you can contact AWS and increase these soft limits as well. But the point is, you can have one or more shards in a stream. And when you assign one or more shards, then you can start ingesting data. And when you ingest data, the records get added to this shard, as you can see in here. And these are append-only records, meaning that once you add a record to Kinesis data stream, you can't delete it, unless, of course, the retention period of this shard has expired. You can define a data retention period. So, for example, you can say keep data for 7 days, or you can go up to 1 year. So, after that retention period, this data in this particular stream or in stream shards will be deleted. Other than that, you can't directly go and delete these records. And the other important thing is, when we are consuming data from a particular shard, we can attach one or more consumers to consume from the same shard. For example, have a look at this. Let's say I have multiple consumers, EC2 instances, AWS Lambdas. Now, when I connect multiple consumers, they can process the same message. And unlike in queues, once a message is being processed by a certain consumer, it's not going to get deleted. So the message will still be there, and the other consumers can then pick up the message and start processing that. And the next thing is, since we can have multiple consumers, how do these multiple consumers knows what is the last message it processed? And that's where we have something called sequence number. Each record added to a Kinesis stream includes a sequence number, and the consumers maintain the sequence number that it had processed. So you can have one or more consumers, like I mentioned. So let's say there are 2 or 3 consumers, and these 3 consumers can individually maintain what is the sequence number that it had lastly processed. So next time it's start processing it or continue, it can pick up from where it left off. So that's how multiple consumers can consume the same messages. So for a given shard, these messages are in the order the way that they were ingested. So they are ordered in the ingestion order. So like I already mentioned, so consumers can process these messages in order, and this order is guaranteed within the shard. However, there's one exception. unless of course you are not using a parallelization factor in Kinesis. So if you are using a parallelization factor, that means that you can process these messages in a given shard parallelly. So in that case, the ordered processing is not maintained at the shard level. However, the ordered processing is maintained at the partition key level. Let me tell you what that is. So for a given record, we have a partition key and a sequence number. So when you are ingesting, we have to define what that partition key is. So like I already mentioned, then Kinesis have a hash function, and hash function will determine which shard it should go to. So that's the first thing, right? And then we can optionally define a sequence number as well. Or else if you don't define a sequence number, Kinesis will automatically include a sequence number too. So if you are parallelly processing a shard, then the order is only maintained at the partition key level. So all the messages have the same partition key will be processed in the order that they arrive. And if you are not parallel processing the shard, then the order will be guaranteed to all the messages in that particular shard. Because remember, one shard can include messages from different partitions. We have hash function, right? So same hash function. So the same hash function. So this particular hash function can receive any partition key, and it's going to spit out the shard number. So it's possible that partition key 1 and partition key 8 can have the same shard number. All right. Next, it's important to understand some limits. For a given shard, you can ingest up to 1000 records per second or 1 megabyte data per second, whichever comes first. So if you go beyond this number and you have only one shard, then your Kinesis data stream is going to throttle, or write throttle rather. So in order to prevent write throttling, you can define some matrices on these numbers, 1000 records per second or 1 megabyte per second. And when they are close to reaching these numbers, you can add additional shards to your data stream. That's one option. Or the other option is you can use the on-demand Kinesis data stream. We'll talk about that just a little bit. But either way, one shard can only accommodate 1000 records per second or 1 megabyte per second, whichever comes first. So that is at the producer part, when you are producing data into the Kinesis stream. And the consumption part also, we have these limits. So the consumers can only do up to 5 reads per second or 2 megabyte per second data consumption. Now this is for a given shard. For example, let's say that you have 6 consumers consuming from this shard, and all these 6 consumers trying to read once per second. So at that point in time, you get read throttling because you can only read up to 5 times per second. Either that or 2 megabyte per second. So whichever comes first. So if I elaborate just a little bit on these 1 MB and 2 MB. So let's imagine you have a data stream and each stream record is 512 kilobyte. And now we are trying to ingest 3 of these records into the stream, and that streams only contain 1 shard. So 3 records is like more than 1 MB, right? So that way, this is only, it's only 3 records. So it's well over 1000, but the total size of these 3 records is greater than 1 megabyte. Again, you experience write throttling. Hope it's clear. So the next thing is, there are 2 modes for Kinesis data streams. First one is on-demand mode and the other one is provision mode. So if you're using on-demand mode, you don't have to worry about shards. So that, the number of shards will automatically be maintained by Kinesis service. The shard level is abstracted away from you. So you have to only worry about stream level limits such as 4 megabyte per second write capacity and 8 megabyte per second read capacity are the starting limits of on-demand mode, and this is applicable for the stream level. But if you need more fine-grained level, then provision mode lets you decide how many shards you exactly need to handle your stream processing application. And you have more control here in the provision mode, because in the on-demand mode, it can takes up to 15 minutes to auto scale. So let's say now you're exceeding this 4 megabyte per second write capacity or 8 megabyte per second read capacity. In order to auto scale to the next level, it can take some time. I think it's 15 minutes. And it can auto scale up to 200 megabyte per second and 400 megabits per second read capacity. So when should you use on-demand mode versus provision mode? Now here's a small guideline. So on-demand mode is suitable if you're experiencing some unpredictable traffic. So let's say if you can't reliably predict, okay, this is the throughput or the traffic for my stream processing application, you probably use on-demand mode. Or else if you know exactly what is the throughput, the request per second or transactions per second for your application, then it's predictable. Then you can calculate how many shards that you need in a stream, and you can go ahead with the provision mode in that case. On demand mode, it auto scales. But here in the provision mode, we need to handle scaling by adding or merging shards manually. On demand mode, we can't predict the cost because the shards can auto scale, so it has variable cost. But here in the provision mode, you know how many shards that you provision, and the cost is predictable. And in provision mode, there's no any capacity limit, so you can define as many shards as you need. So there are no any hard limits for number of shards that you can define for a particular stream. All right, so that's the difference. So far we discussed about Kinesis data stream. Now it's time to talk about Lambda. So as we have discussed, for a given Kinesis stream, we can have one or more producers producing to that particular stream. And then we can have consumers that are consuming from this stream. Now, as for the producers, you can have EC2 instances or web or mobile clients, traditional servers, or IoT devices that will be pushing these messages into this Kinesis stream. And here for the consumers, you can have again EC2 instances, containers pulling this data. And you can also use serverless consumers like AWS Lambda, which is our main focus. So when you're using AWS Lambda as a consumer, AWS Lambda needs to pull these records from the stream. So here in this diagram, this is our Kinesis stream. So the producers are pushing this or ingesting records to the Kinesis stream. And then we have AWS Lambda. So this whole thing is AWS Lambda service. So in AWS Lambda service, we have this resource called event source mapping or ESM. So ESM or event source mapping is the resource that pull messages from this Kinesis data stream. So AWS Lambda has this event source mapping resource and pulls these messages from the Kinesis and then invoke AWS Lambda functions. So when we are invoking this Lambda function, we can pass a batch of messages as well. So event source mapping can do that. Not only batching, but it can do many other things. Let me show you. So here we are. So for Lambda event source mapping, we can configure these things. Starting position, batch size, batch window, report batch item failures, retry attempts, maximum age of a record, failure on failure destination, split on errors, concurrent batch per shard, tumbling window, filters. There are so many configurations that we can configure at Lambda event source mapping. So in this crash course, we are going to focus about starting position, batch size, batch window, report batch item failures, retry attempt, failure destination, split batch on errors, so on and so forth. Let's understand this configuration with a demo.
So I'm at AWS Console. So here in the search bar, I can search for Kinesis. So this is a service, you can even bookmark it. So here in the landing page, I can start creating a Kinesis data stream or Kinesis data firehose or even Kinetics data analytics application. Now here's a handy pricing calculator. You'll see how much you'll be charged for per shard per hour. So here in this North Virginia region, it's $0.015 per hour. And in addition to that, when you're ingesting data, there's another additional charge to it. Now if we select Kinesis Firehose, now it's only charged for the data ingestion. See, there's no any hourly cost, and if you do not ingest any data in a month, you won't be charged. That's truly a serverless service. But here I will select Kinesis data stream and go ahead and click create data stream. Can give it a name, and then I'm supposed to select the capacity mode. Is it on demand or provision? So here for this demo, I'll select provision. Then I have to define how many shards do I need in my stream. I'll keep it just one shard. You can create up to 500 shards per stream, but this is a soft limit. You can always contact AWS and increase this quota. Then to give you some information, what's the write capacity and what's the read capacity. Like I mentioned, if you have just one shard, your entire stream throughput is 1 megabyte per second and 1000 records per second. So if I make it 2, then it becomes 2 megabytes per second and 2000 records per second. You get the idea, right? I'll keep it back to 1. That's all. And I'll go ahead and create the stream. So it will take a few minutes. Here we go. Now it's available. And now that I have a data stream, I can start producing data to it or ingesting data to it. So here in this section, you have the producer section. Here I can use Kinesis agent. I can install this in a server. So this is a Java application, and then start sending data to this stream. I can also use AWS SDK, and I can also use another library which is specific for Kinesis, which is called Kinesis Producer Library. Now this has some additional capabilities, but we'll look at it a little later. And then underneath that, we have the consumers. So once you have data in the stream, you can connect a Kinesis data analytics application, or else you can push that data to a Kinesis data firehose. So you can batch and put them into different targets. And you can also use Kinesis client library, the KCL. So if you have used KPL to produce the data, the KCL can be easily used to consume that data as well. But here AWS Lambda is not particularly mentioned, but you can go to AWS Lambda service, which I have already bookmarked, or you can just search for it, Lambda. Open it in a new tab. Now go ahead and create a function. I call it stream processor. And then I'll go ahead and create the function here. Now from the Lambda console itself, I can attach the triggers that trigger this Lambda function. So if you click add trigger, then I can select a source. In this case, I can search for Kinesis. Here we go. And then I can search for the Kinesis data stream in this region, which is my first stream. Here I can enable the trigger, and there are a bunch of configuration like the batch size, starting position, batch window, and additional settings. What happens if something got failed, retry, tumbling window, so on and so forth. We are going to learn all about that in this course. But right now, I'll just go ahead and click add. And here when I click add, I get an error. It says, please ensure the role can perform get records, get shard iterator, and few other actions related to the stream. Now this is essentially, as with any other thing in AWS, in order to communicate between two services, the proper permission should be declared. Now how are we going to do that? So in this case, the Lambda is going to pull the data from the stream. So we have to associate this permission using an IAM role to this Lambda function. Now IAM is the service that we can grant permission to AWS services, AWS users, so on and so forth in AWS ecosystem. So here right now, if we go to the configuration section of my Lambda function, you can see there's the permission tab. And there's automatically a IAM role created for this Lambda function. Now this IAM role defines the permissions that this Lambda function has. So I can click into it. It will open the IAM console, and the role section for this IAM role is open. And here under the permissions, So this is the current permission that Lambda automatically has added upon creation. So it's only allowing it to log data to CloudWatch. It doesn't have anything related to Kinesis. So what we can do here is to add some additional permission. So I can click add permission to this role, attach policies, permission policy. Let's search for Kinesis. Now here we have a bunch of managed IAM policies. Now these are managed by AWS. You can create your own policy as well. But for now, I will give Amazon Kinesis read-only access. So I'll attach this policy to this particular role. So then this role will have that permission. If you scroll down, you can see here. Now this role is attached to the Lambda functions, meaning that our Lambda function also has the read-only permission for any Kinesis stream in this account. You can be as granular as you want with IAM permissions, but this is just a small demo. So I'll go ahead and add the trigger again, and let's see if this time I can create this trigger correctly. Select the service. I'll go ahead and click add. There we go. Now it's properly created. In the UI itself, you can see our Lambda function is triggered by this Kinesis data stream. Now this is just an overview. We have to go in detail. How does this integration happen and what are the considerations, and also we will build a stream processing application with Kinesis and AWS Lambda. Okay, so here I am at the AWS Console, AWS Kinesis service, and we have created a data stream, and here I've called it as a test Kinesis data stream. So what I want to do is I want to go to AWS Lambda console. You can search for Lambda here. I've bookmarked it as well. So if I just open it up, then we can create a Lambda function. I've already created a Lambda function, so let's go into that particular Lambda function. So right now this Lambda function is not invoked by anything. See, there's no any trigger set to invoke this Lambda function. So let's go ahead and click add trigger, and then we are supposed to select a source. So here I'll scroll down to Kinesis and select that. Then we can select that Kinesis data stream we created previously, and make sure you activate this trigger. And here are the configuration I just mentioned in the slides. So first we can set the batch size. So this is the number of records in each batch sent to the function. So this is rather the maximum number. So for example, I can set it to 50. So that doesn't mean it's going to send a batch of 50 records always to the function. It could be less than that. Because remember, the event source mapper in the Lambda service, it will poll the stream in every second. So whatever the number of records that is captured, during that 1 second, if it is less than 50, it will send directly to the Lambda function. If it is more than 50, it will break it into 2 batches or 3 batches, and then send those batches into the Lambda function. Next, we have the starting position. Here we have the latest one, trim horizon, and a timestamp. Latest one is, so here if you set to latest, it will only send the latest records. If you set the trim horizon, it will start sending all the record in the stream, or else you can set a timestamp. From this point onwards, send the records to the Lambda function. Then we have the batch window. Now by default it's 0. So you can set the batch window in seconds. So you can set it to 30 seconds like I mentioned in the slides. So batch window and batch size, they work together. Next, if you open the additional settings, then you will see there's this on failure destination. So here I can set up a queue or a SNS topic ARN, and then the retry attempts. How many times should we retry if the records could not be processed by the Lambda function? And then the maximum age of the record. Now this is the maximum age of record that Lambda service sent to the Lambda function, or the event source mapper sent to the Lambda function. You can set this in seconds, and this is very important. Now imagine for some reason the Lambda functions couldn't process these records for some time. So let's say it could not process records for 3 hours. This could be due to one of the downstream services is not working, so Lambda couldn't actually process these records. Now once those downstream services come back online, then the Lambda can process the records. But now Since Lambda couldn't process the last 3 hours records, event source mapper will collect all the records from the last 3 hours and send in batches. So there's a huge back pressure for the Lambda function. So it's unable to process whatever the real-time records that the Kinesis data stream receives. So that's why this maximum edge of record is important. So this will tell the Lambda service or the event source mapper, do not send the records in the stream to the Lambda function if it is older than the max age. And then we have split batch on error. So here it says, if function returns an error, split the batch into 2 and retry. Let's say the Lambda function received a batch of 50 records, and while it is processing, there was some error, and then the Lambda function returns an error. So here it's not returning this partial successful response. Instead, it will return an error. So when the Lambda function returns an error, the event source mapper will retry that whole batch. But if you set this split batch on error, then it will split that 50 records batch into 2, meaning that 25, and send a batch of 25 records into Lambda function and try to process that. Now, if that is also failed and the Lambda return an error, again that 25 batch will be split into 2 and try that out. So likewise, the event source mapper will keep splitting the batch into 2 and try to find those failing records and finally send them into the failure destination. And then we have more configuration like concurrent batches per shard, tumbling window duration. Now, before learning more about that, let's do some practicals because we learned a lot of theories. So to consolidate that knowledge, we have to do some hands-on. Alright guys, so welcome to this practical session. Now, in this practical, we are going to implement this architecture. So essentially, we have an application and that will publish telemetry data to Kinesis data stream. And in order to publish that, we'll be using AWS SDK for JavaScript. And then this data will be added to Kinesis data stream in real time. And then in the Kinesis data streams, we will be attaching AWS Lambda. This is the AWS Lambda service, which will pull the data in batches and then invoke Lambda function. And in the Lambda function, we will iterate these records in a certain batch and then log those messages or the records in CloudWatch log. So here from our telemetry app, we will be publishing temperature data, pressure data, wind speed, and they will be landed in the Kinesis data stream. AWS Lambda is connected with event source mapping like we already learned. And then event source mapper will pull these data in batches and then invoke the Lambda function. So let's go ahead and implement this. Now in order to create these resources, I'll be using Serverless Framework and CloudFormation. Now all the code related to this practical is available in this particular GitHub repository. I'll share this link with you all. So go to this repository and then copy this repository URL and then take a terminal or command prompt if you're using Windows. And I'll go ahead and create a new directory. Kinesis practical number 1 and cd into that directory, and then I'll do git clone, paste the URL I just copied and then hit enter. So that will create this folder Kinesis course. Go into that, and this is the code that we have right now in that folder. So let's open it in Visual Studio Code. So I'm using VS Code as my code editor. You can use any preferred code editor that you want. When you open it, you will see there are a bunch of files. So one of the major files is this serverless YAML file. So like I mentioned, I'll be using Serverless Framework to deploy my resources to AWS, which include Kinesis data stream and a Lambda function, and also the associated IAM permissions. So if you haven't used Serverless Framework before, you can go to serverless.com and there's this getting started guide. So first and foremost, you need to have Serverless CLI installed. So I've already installed it. Let me show you the version that I'm currently using. I'll take an integrated terminal in VS Code and I will do serverless-v. So the version that I'm using is 3.25.1. So if you don't have the CLI already installed, just copy this and paste it, and make sure add at the end, and then use the same version that I'm using right now. So that way you will be able to follow along exactly the way I'm doing right now, and hopefully you won't face any issues. So now let's walk over the code. So this is the main file, the serverless configuration file, and there are a bunch of attributes. First and foremost, we need to name our service. Here I said this is KP1 for Kinesis Practical 1, and the serverless framework version that I'm using is 3, and then we have this provider section. So here we are deploying to AWS, and for the Lambda runtime, we'll be using Node.js 12, and the stage is dev, and the region is US East 1 or the North Virginia region. So all these resources will be deployed to North Virginia region in AWS. And then I'd like to get your attention to the resources section. Now in serverless framework, we can define pure CloudFormation in order to deploy our resources to AWS, or else we can use some abstraction provided by the framework as well. But in order to deploy our Kinesis data stream, I'm using CloudFormation. Now this is exactly pure CloudFormation. So under this resources section, I'm creating my CloudFormation resources. So I've named it as KP1 Kinesis data stream. I will just call it KP1 data stream. That's much shorter. And it's the type of AWS Kinesis stream. And then I'm defining the properties. So as for the properties, I'm setting the shard count to 1. And also I'm using the provision mode of Kinesis data stream. So we learn about there are two modes, on-demand mode and provision mode. So we are using provision mode, thereby we have to define the shard count, and I'm starting with 1. So there will be only one shard in our Kinesis data stream. So how do I know these values? Well, that's quite straightforward. You can easily search Kinesis CloudFormation, and then you will be landing into this AWS documentation. So this is the CloudFormation documentation related to Kinesis, and there I'm using YAML version. So you can see the type is this, and then I'm defining the properties. So these are the properties that Kinesis data stream supports. Now none of these properties are required. So how can we quickly check that? If we do a search in this page and type yes, so there's only one yes, this button, but other than that there are no any yeses. If one of the properties is required, then in the required section, instead of no, it will be yes. So you can easily find out what are the required properties. But here in this Kinesis, there are no any required properties. I'm not going to name it by myself. I will let the CloudFormation to name my Kinesis data stream. And this is actually a good practice because you don't have to worry about name collision when you are deploying multiple resources to AWS, or when you are deploying to different environments and so on and so forth. All right, so coming back, then these are the properties that I'm setting at the beginning: shard count and the stream detail, and they are the stream mode to provision. And then in the output section of the CloudFormation, I'm outputting the name of the Kinesis data stream. So this is the Kinesis data stream name. And for that, I'm using this ref intrinsic function and pass the logical name, because since I don't specify any name, the easiest way to refer to a resource is by its logical name. So I'm using ref intrinsic function and the logical name which I define here. So this is going to return the Kinesis data stream name. So how do I know that? So if we go to the same CloudFormation documentation of Kinesis, you can scroll down all the way down, and then there's this returns value, and there are two intrinsic functions that we can make use of, ref and getAtt. And if you specify ref with the CloudFormation logical name, and that's going to return the stream name. So that's how I know to use ref to return the name of the data stream. All right. So here we use pure CloudFormation. And then I'm going to use serverless framework some abstraction to define my Lambda function, so that I can create the Lambda function, the Lambda service and the Lambda function, and then connect this Lambda function to Kinesis data stream. So whenever the data is available in Kinesis data stream, it will poll the data and then invoke the Lambda function. So let's see how to do that. So in the function section, I've given a name, the logical name for my function. Here also I say kp1 consumer. This is my Lambda function logical name. And for any Lambda function, we need to define its source code. So that we define with the handler attribute. And all my consumer Lambda function code is available in the functions folder. And there's this file called consumer. So here you can see on the left side in the function, we have this consumer.js. And in the consumer.js, I'm exporting a function named handler that will take the batch of records from Kinesis data stream and then iterate over that records and finally do a console log. So here I am logging each record information into CloudWatch log. So this is the code that is there in this particular Lambda function. So AWS Lambda service will pull the data in batches and invoke this Lambda function. That batch of records will be received in the event object. So what we do is we go into the event object and then it's available in the records attribute. So all the records are available. And then I am iterating it. Now Kinesis data stream contains data records in base 64. So the Kinesis data stream will contain data in base 64. But when you are reading it, we need to convert that data record to UTF-8 so we can understand that. So that's why here we are using JavaScript buffer from function. This is the native function and this is one of the record data, and then we are converting into UTF-8 string. So this is the decoded data. And then we can JSON pass those data because this will be in a stringified mode. So if we ingest data as an object, so this will be a stringified object. So I can pass it and then I can do whatever I want to do. So here I am console logging it. So when I'm console logging it, again I am stringifying it. So this is actually repeated work. So what I would do is I will just comment out this passing part and then I will be directly sending this decoded data that is in stringified mode. So this is the code in the Lambda function. So now, how do we connect this Lambda function and the Lambda service with Kinesis data stream? Now here also, we are going to use serverless framework. So it has this abstraction. Whenever we are defining a Lambda function, we can set the events that's going to trigger this Lambda function. Because as you already know, Lambda functions needs to be triggered by an event source. So the event source that I'm using right now is a Kinesis data stream. So I'll be using -stream and the type is Kinesis. And then I need to define the Amazon resource name. So this is the uniquely identifiable resource name in AWS for our Kinesis data stream. So how do we get that? Well, we already defined our Kinesis data stream right here. And this is its logical name. And now I'm using another intrinsic function called getAtt or getAttribute. I'll go into the Kinesis data stream and there's another attribute called ARN, Amazon resource name. So I'll access that and then it will return the ARN of the Kinesis data stream that the CloudFormation is going to provision. Now you can find that details in the CloudFormation as well under the return values of CloudFormation of Kinesis. Here you see the getAtt, getAttribute, and then there's this ARN attribute. So I can do getAtt ARN. And this is a shorthand for that. So you have this bang sign and getAtt Kinesis data stream.arn. Okay, with this we have connected our Lambda service and the Lambda function with the Kinesis data stream. But now when the Lambda, AWS Lambda service or the event source mapper in AWS Lambda trying to pull the data, we need to give some permission to this Lambda service. So that's where I'm defining my IAM role statement and allowing this permission to the AWS Lambda service. So one of the actions is Kinesis describe stream summary, get records, get shard iterator, list shards, list streams, subscribe to shards. Now these are the specific permissions that the Lambda service is required to pull the data from the Kinesis data stream. Now giving this permission in a granular way is the best practice. Or else you can also use a wildcard, for example Kinesis star. So this will give Lambda the full permission to access the Kinesis data stream that we define in the resources section. So here in the resource section, I'm again using the same get ATT, the same intrinsic function we use here to fetch the ARN of the Kinesis data stream. So if we use this wildcard for that Lambda function, then this Lambda function will have full access to this particular Kinesis data stream. But I will revert back to the granular permission. So we are following the security best practices. All right. And then up here in the plugin section, I'm installing a separate plugin called Serverless IAM role per function. Now this plugin is required for serverless framework to define these permissions in function levels, because in serverless framework I can define one or more functions in a serverless YAML file. If we are not using this plugin, we have to define this IAM role permission at the provider level, and the permission will be associated with all the Lambda functions. Now we don't want to do that because we need specific permission for each function. So that's what this plugin enables us to do. So when you use that plugin, I can define my IAM role statement function wise. All right, so that will be it. So let's go ahead and deploy it and see how it connects. So I will take a terminal and I'll make sure I'm in the correct folder. So I can see the serverless YAML file is right here. So now I can do serverless deploy. Now before you do this, you need to have AWS credentials set up in your local computer. So here you can go to AWS IAM service and create an IAM user, maybe with admin permission, and then configure the access key and the secret access key in your computer. But in my case, I'm going to use some temporary credentials from AWS using AWS SSO. And I will just go here and grab my temporary credential and set them at my editor using environment variables. And then I will do serverless deploy. Well, I get an error. This serverless IAM role per function library is not installed because we are referencing it in the package JSON as a dev dependency. So make sure you do npm install, npm I or npm install before you running that command. Okay, let's try that again. Serverless deploy. So this time it's packaging and creating the CloudFormation stack and then deploying my resources to AWS. All right, so it is deployed. So let's go to AWS Console and see these resources. So I'll go to my AWS Console and let me go to Kinesis. And there's one data stream already available. Let me go into that. And here we go. So this is the data stream that CloudFormation has provisioned for me. So it has given its own name, which is good. And the shard count is also 1, so it's fine. So let's go into that. Now here in this section, I can see the capacity mode is provision and the data retention period is 1 day. Now this is the default data retention period, 24 hours, so 1 day. Since we didn't define it in particular, so it is using this default value. Okay, it looks our data stream is created. So now let's go to Lambda. I should see my Lambda function as well. So kp1 dev, kp1 consumer. Let's go into that. So Kinesis data stream is already connected with this Lambda function. So now let's go ahead and click this Kinesis data stream. So I can see more information related to this Lambda and Kinesis integration. So here I will expand this details section. And when we use serverless framework, it has added some default values. I can see the trigger is now active. So if we add messages to Kinesis data stream, it's going to invoke the Lambda functions. And by default, the batch size is set to 10. And batch window is set to 0. And the concurrent batches per shard is 1. Maximum age of record is -1. Now this means infinity. So there's no any maximum age defined. Retry attempts is also -1. So that means if there's any errors from the Lambda function, it will keep retrying. And it does not use split batch on error. And the starting position is trim horizon. So the Lambda function will start consuming data from the beginning of the Kinesis data stream. All right, so these are the default value. So let's test this out, right? So the batch size is 10. So let's go back to our code. And then I will go to the producer.js. Now this is our producer application, which is this telemetry application. So this is a simple Node.js script, and it's using AWS SDK to put the data into the Kinesis data stream. So let's have a look. So here in this JS file, I'm requiring AWS SDK because we are using AWS SDK for that. And here I'm accessing this Kinesis SDK. And then I need to define my stream name. So let's go to CloudFormation. I can copy the name from here, or else I can just go to CloudFormation since we added it into the output section. So this is that stack. Let me go into that. I'll go to the outputs. And here we go, the Kinesis data stream name, and that is the exact name that we saw in the Kinesis data stream. So let me copy that, and here in the placeholder, so let's replace that. All right. Then in this producer.js script, we only have this one function that will trigger in every 500 millisecond. That means in every half a minute, this function will be triggered. So I'm using set interval in JavaScript. So what it does is basically it will randomly generate some temporary value, wind speed and pressure, and then create an object called telemetry. So in this object, it will include the temporary value. So in this object, it will include the temperature, wind, and the pressure. And then we will put this record into Kinesis using Kinesis put record API. So in the SDK, we have this Kinesis put record, and there I am adding this parameter object. So this parameter object, here I am adding that telemetry object, and make sure we need to JSON stringify that. So here we stringify that JSON object, and we also have to add the partition key. Now this is a mandatory attribute, but here I just hardcode the partition key 1, 2, 3, 4 because we have only one shard. So even if we use different partition keys, all the records will be landed into this particular shard. So I will just hardcode it right now, but later we'll see how to use multiple partition key and then use parallelization factor. But for this example, the partition key is hardcoded. And then the stream name, which we just put up here. And finally, we use kinesis.putRecord. And then if there's any error, we will log the error, or else we can log the data, the confirmation of adding this record into the Kinesis data stream. So now let's go ahead and run this script. In order to run this as well, you need to have the AWS permission properly set up in your local machine, otherwise it won't work. So let's run this Node.js application. At the end, you can see it's calling this generate telemetry function. So what I just need to do is do node producer.js and hit enter. Now here we go. It's printing the shard ID and the sequence number. So all the records are landing into the same shard ID because we only have one shard, the 0th shard. So it's keep getting adding. So let's see whether our Lambda function or the Lambda service pull the data in batches. As you have seen, by default, it's pulling in 10 records batch and invoke this Lambda function. And then the Lambda function will iterate it and log it into CloudWatch log. So I'm here at the Kinesis data stream, and let me do a refresh. I should see some incoming data records. There we go. I'm receiving incoming data, and also the data is getting read as well. Can you see? So our Lambda service is reading data by batches, and the Lambda function is getting invoked after that. So let's have a look at the Lambda function, and this is our Lambda function. So I'm in the AWS Lambda, and I'll go to this monitor section, and then I can go to the CloudWatch logs. So I will see the log messages, and here we go. I see one stream, so I'll go into that log stream, and then I see the log records. So let me stop our script, so it will stop producing data, but have a look at this. So this is the time the Lambda function has started, and then it has printed 2 records, and the Lambda function has received 2 data records, 1, 2, and after that it's ended. and then another Lambda function got invoked. Can you see there's a start, and then it process one temperature record and process another temperature record. That means it has received two temperature record as well, and then it ended. So likewise, our Lambda function is only receiving 2 or maybe 1 or 3 items at a time. Although we set the batch size to 10, it's not receiving 10 by 10. Now why is that? Now we have already discussed this in the theory section. If I open the configuration again, I'm only attaching a batch size. So batch size is 10, but batch window is none, that means 0. So Lambda service is not waiting for any time to collect the data record and then invoke the Lambda function. So the wait time is 0. So here the Lambda service will poll the data stream in every second, but it's not going to wait any seconds to collect the data. As soon as it hit it, it fetch whatever the data that the stream has it, and then invoke the Lambda function with the data it has collected. Now if we want our Lambda service to wait for some time before returning, we need to define the batch window time. So how do we do that? Now in Serverless Framework documentation, I can go to the events, and then I can go to Kinesis and DynamoDB events, because right now we are using Kinesis as an event type. Now in this documentation, if you scroll down, you'll see we can define the batch size. By default it's 10. So let's go ahead and again define it explicitly. Come here, and here let me add the batch size to 10. So there's the default value, by the way. And if you scroll down further in the documentation, you see the batch window section. So I'll set the batch window time as well. Let me copy it here. I will set the batch window to 10 seconds. So let's see. So if we set the batch window to 10 seconds, how many records should the Lambda service will collect? In our producer, we are pushing the data to Kinesis data stream in every 500 milliseconds or in every half a second. So if you are waiting 10 seconds, then there should be 20 records. So ideally our Lambda function should see 20 records. But as we have discussed, it's not just the batch window that is taken into consideration. Lambda service will also consider the batch size as well. So here the batch size is 10. That means maximum number of records that we can send to Lambda is 10. So although we get 20 records waiting 10 seconds, so after 5 seconds of wait time, when it accumulates 10 records, it's going to invoke the Lambda function. So let's deploy these changes to AWS or update the Lambda service and see the behavior. So I'll do SLS deploy or serverless deploy. Alright, so the deployment is complete. So let's go to AWS, and in the Lambda function, under the triggers section, so let's refresh it. I should see the batch window now properly set to 10 seconds. Let me click here again. Here we go. Now the batch size is 10, batch window size is 10. So let's start our producer application one more time. Node producer.js. That will start publishing records. Now after a few seconds, let's go to the CloudWatch logs again. I should see a new stream. Let's see. And here we go. Now there's a new stream. So let me click into it. And now do you see? This is the starting time of the Lambda function. And then it has received 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 records. And then it's ended. Again another Lambda function is started. And then it has received again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the records that is getting published, the temperature, wind and pressure records, and it's ended. So as expected, Lambda is receiving 10 records at a time. So I hope it's clear how the batch size and the batch window work together. So this is what I wanted to show in this practical. Alright, here's a quick reminder. So if you are following along, make sure you stop the producer and then delete the stack, because we are using the provision mode in the Kinesis data stream. So if you do not delete your Kinesis data stream, then you will be charged hourly. So in order to prevent that, make sure you do serverless remove. So that will remove the entire service, including all the resources that it has provisioned, function, and the Kinesis data stream as well. So you won't be charged. Otherwise, you will be potentially charged. So that's why I mentioned this Kinesis data stream is not really a serverless service. Of course, it's a managed service, but it's not a serverless service. Even if you're not using it, you will be charged. So now it is deleted. So let's go ahead and check our Kinesis data stream. So this is the Kinesis data stream, and let me refresh it. This should be deleted. Alright, so it is deleted and it's getting me an error. Similarly, the Lambda function should also be deleted. So if I refresh it, yeah, the Lambda function is also gone.